and know the clinical story or the surgery. I enter to the operating room.
I'm not interested in the surgery. I just want to see the signal. You see.
Yes.
The signal
is. I say
the
signal and the MRI.
Yes.
MRI.
Before you show
the tractography.
Yeah.
Tractography.
Yeah. Before you show me, I got some reference. I show you first. I think it's I prepared a lot of picture here. Can you see? This is a publication by a research group, and he argued they have detected the signal from neuron. Can you see?
Yes.
So is that the same?
Yes, this
same
is
pattern?
Yes. This pattern is from one neuron, and this is the membrane potential.
Yes.
Chain.
But I have question to ask you. You see, I examined the equipment. So this is their equipment they use. This is electrode. Can you see this is the cross section of electrode?
Yes. Yeah.
And there are several points where you can detect the current voltage.
Yes.
Then the smallest is this side. Can you see this is smallest? So this is the same size I used for this microscopic picture of neuron. So this is the smallest.
This is a size of 50 micro.
Yes, that's right. Yeah. However, my question is, how can they so sure that even use the smallest electrode, how can they show that the signal is picked up from the individual neuron? Can you see?
Yes.
This is the size of neuron. Can you see? This is 1:1, so same scale. You can see.
Yes. And the electrode we use are larger than that.
Even larger than that, right?
Are 10 millimeter, 1 centimeter.
So the smallest, this is the smallest. Yes. You see, this is smallest.
It's a small quantity of neuron, but it's a group, cluster of neuron.
Cluster, again. A class of neuron, not an individual, a cluster.
Because the size of the neuron, and this is eloquent, is not this dimension of this electrode, macroscopic view. This is microscopic view.
You see, that's I think when we talk about the signal direct pickup from neuron, I have question. I have always a question mark. How could people show that is actually directly detected from that similar to this diagram? Can you see?
How
can you know? They are supposed to.
Answer is from the neuron, but it's polemic because some people think that all the activity we register is from the thalamus.
Yeah.
Other structure internal. But it's possible the theory that the signal come from the neuron.
Well, they are influenced. Could I say the signal is influenced by the signal in between the neuron?
Yes.
But
other neurons
maybe there are other noise, background noise, like you detect the gravitational wave. You have background noise, and then that is why in this So I think this okay, you can show me some of your data. So this,
this point is very important, because in medicine it's not science. In medicine we use some data until the scientific knowledge improve, and we say we use new paradigm.
New concept.
And medical is not repeating. And repeating a good medical is thinking that's not all. That's one model. All models have good things and bad things.
The merit and shortage, shortcome. Yes, that's right.
Yes. But you have reason. You have right. You are right in the dimension of the we observe the activity of the brain.
Yeah.
But in neuroscience, in neurologists of epilepsy, we have to be the big picture, the patient, the brain, the region, the zone of the brain, to finally tunnel vision examine 100 or 1,000 neurons, a group or cluster, but is the signal is a mix. It's a composite mix of.
Yeah, that's where we're dealing with. You know, we don't know the exactly the structure or the origin, but what we can say is that when you use different method to measure the signal, and that will give you different type of information. Hopefully, we can combine this different type of information to understand the how brain works, right?
Yeah. The information from studies of animals, healthy animals, and from human with disease are contradictory, are the same. For example, in the epilepsy state of the art theory of epilepsy, the gamma waves, are 100 or 500 hertz.
Oh, by the way, Dr. Moya, I have got some pattern to ask you a question. This is diagram from your talk.
Yes.
I can see some pattern. It show me because I'm interested to find the pattern. Now I think I found some. I probably just highlight this one. So if I just show you the pattern. Let me see this pattern. Very interesting. Okay, I use my pen because I'm always looking for pattern. When I put them together, I found something.
You're training. You're training to
you see,
look for.
If you go to this diagonal, this EEG looks similar. You can consider this matrix. Can you see? This is matrix.
Yes.
Because you can see the matrix. You see, and these if I just use the matrix here, so these represent the delta, this is theta, and these represent alpha. You see, and these don't know if you just pick up a back, but what I know is very important. This is a pattern I see. I'm surprised. Can you see? These three patterns look similar.
Yes, if we have
and these two
closer time,
these
we
two
have the
look
movement.
Similar.
We have a moving wave in the brain. These colors change in a sinusoidal form, like a wave.
Like wave.
See, but the time here in this example is separated with very 1 minute, 2 minutes, and here it is not the same. But the pattern is because I show this diagram is similar. I show you one patient with a similar pattern, and in my opinion, in the left column. Alpha is active.
Artifact.
Yes. I presume in the left column the patient is with the awake with the eyes closed eye, and in no thinking. Because alpha is marked in red. Red in the scale is high voltage, high amplitude. And in the middle, the column of the middle, the patient is in another state. I think because theta is predominant, and in the midline, C theta, C theta. I presume that is an example of a sleepy patient. Is entered to N1 first stage of sleep.
So well, can we just take, I just take some note from you, and so we probably were, let me see, I just withdraw that. One moment.
Because I will connect the.
So which is a sleep? This is sleep. Which is sleep? Which deep sleep?
This sleep is N3.
Which one? Which one is sleep? Which one?
The middle.
The middle is sleep, right? Sleep.
See, middle. The left is probably no. It's very
wake up.
Wake.
Yeah.
With relax and
relax
eyes.
Or wake. Yeah. Wake and
relax.
And
the right is definitely in sleep, in this deep sleep.
Deep sleep, right?
Because delta is predominant.
Sleep.
Yes. Yeah. But I
that's interesting.
I don't know the source of these samples. I view the time, the hours, and are closer, huh?
Well, you see, if you do some mass transformation, if you manage to do the mass transformation, what can we do? I just show you, because this is it's interesting, because I many years ago, 40 years ago, I solved the puzzle in physics, which have same pattern of this. The diagonal matrix with different phenomena, but can you see if I draw some translation? Can you see? If I just I just show you something interesting. Let me see. So if I just do translation, so this is this is blue. Can you see? And this is yellow. Of course, it's very rough at the moment. It's not exactly this. I simplify that. So if I just drop this bar, I put it down. I put it down, so that you will see that if I put this yellow down, and that yellow will be here. Can you see? So I put this yellow down by this one, and that became red. Can you see?
Yes.
So if I just continue, if I put this down, if I just do some transformation, I put this two matrix down. Can you see? I put these two matrix down. We will get this pattern. So that is starting from red. Can you see? They're starting from red, and then follow the green.
Yeah.
So therefore, we can argue this is green as well. Can you see? This is so follow this pattern. So the sequences. If you look at the sequences, that sequences can be called as blue, yellow, red, and green. Can you see? No matter which you go the same. Can you see? This is yellow. Can you see?
Yes.
So this is blue. This is yellow, red. So this is order. Can you see the order?
Yes. If we have an artifact, we have a jump from one color to representing frequency, and in the immediate second, other color, other amplitude, or potential very away. This is artifact.
Because it's artifact. Okay.
When it's biological, when it's a genuine bioelectric signal, is a gradient between.
You see, you see, I'm trying to explain this pattern. Okay, how can we start, or whether should we use the more reliable? I'm not sure, but I'm trying to explain this pattern in this circle. Can you see?
Okay.
I'm trying to explain why this pattern looks like this. And this is some of the preliminary pattern, you see. Anyway, if you tell me if any is, if you can see similar pattern, you need to
make sense to me. Make sense to me. I learned from you standing wave and review that. And I think that this pattern is real. I saw in each exam, EEG have this pattern.
Oh, good. So let's just stop here. One moment. We'll go back to that. The pad screen, yes. Okay, so that is my comment. Of course, this is different display. In this case, they rotated the brain, right? So we cannot see. I tell you what,
it's 3D. This is 3D.
I tell you what, Dr. Moya, I have another idea. It just occurred to me. So we can empirically to mimic this pattern by building. I show you. I draw some. I give you some. I show you my idea. Right? It's because I think differently from you. Do you agree? Because you people have been there for many years, but I just come. I'm newcomer. Okay. I'm newcomer. I say what can
I need that. I need that, and I learn that's not sure interpretation of the truth of about the brain.
You see, when we studied astrology, okay, when I was in university, when we studied astrology, so teacher to bring us into the dark room. The dark room is that is just the cubic. The beauty is in the dark cubic, right? So we just trying to turn off the night, and we trying to pick up what is a consonant star. Okay, how to recognize a star in the space. So because I have this idea, so when I look at that one, why don't we build something? Can we just see the cross section like this? You build a dome. You build a dome, right?
Yes.
You build a dome, and you use because it's dipolar, right? You use the light, and one side is let me see, this color. So the one side is red, and another side is blue, right? So this is just one of them. So what you can do, you can fix. This is light source. The lamp. Can you see? This is a lamp with a filter. Okay, this is a filter. The red filter. This is red. Okay, they're different color. So you can rotate that. Can you see? You can rotate that. Also, you can rotate a different direction. Can you see? You can rotate this direction. This also you can rotate that direction. Okay, and also in the meantime, you can also adjust the range. Can you see?
And so the change in the register.
Yeah, you can change the angle. Can you see? So, for example, if I want to reproduce this one, do you understand?
Yes.
I just use this light to block this one, so that this light will become red. Can you see?
Yeah. Okay.
Do you understand? And another thing.
Yes, I understand. And the wave is like a signal bouncing, rebouting from one side to another side.
No, because this is just starting. This is step one. Another thing you have, for example, I can also generate this. We can also generate a color like this one. We can also generate this ring. Can you see? This blue ring.
If we experiment with an input in the eyes, flashlight, flash intermittent light.
Yes,
certain frequency.
Yeah, what I'm talking about, we can also generate this pattern because I tell you, when I was young, I'm interested in theater lighting.
Yeah.
Theater lighting.
Yeah.
So we use different color part to generate a spot. Can you see? We can use a search star to generate this effect, the theatrical effect. Do you understand? Right. And sometimes we can, for example, we generate this is a sky. We generate lightning. Can you see?
Yes.
Or sometimes we generate a slow. But just use a pattern. Use a pattern. So
this is pattern.
So see, my point is that we probably can use a finite number. We can start from 2 or 3. of this rotating. It's called rotators. Okay, then we can reproduce some basic pattern you displayed in this continuous EEG signal. So we can
reproducible. Yes.
In that way, we can use a different variable. For example, we can use this theta and this phi to denote this the pattern.
Very interesting. Very interesting.
So because so when we teach astrology, so we just use this. We use this. Actually, they have source here, right? They just source this. This is source, the very bright source. They got a hole here, tiny hole.
Yeah.
Tiny hole here, right? So we can see this is star. Can you see? This is star.
The sky.
Star. Yeah, sky. Yeah, in the dark, at night.
Yes.
At night. Yeah, this is probably something. Maybe your research group can try. Because in
this is interesting. Yes.
So
because
we can mimic. Okay, the idea
is
to mimic the pattern. Mimic the pattern by using, because after all, this is very close to the dipole.
Yes.
I read some articles. They trying to introduce the dipole.
Dipoles. Yeah.
Dipole. Yes.
Yes.
So these
and in the axis orthogonal to the electrodes, to the two electrodes, because it's parallel, no signal.
Yeah. So this is low voltage, right? This is low. This is lower voltage.
Low.
This is high. Okay.
But if we enter and put electrode in the neurons, are active.
Oh.
We detect the movement. We detect the change. The differential in potential between regions.
Yeah. All right. This is my idea. Your turn. Okay. I'll give time to you.